We continue synchronized sequential circuit analysis by some more examples. So far we learned two different models, a Mealy and Moore model, and we learned a state diagram, state table, timing diagram, and state symbol assignment. So let's solve one more example for the following circuit. Find the state table, part A. Okay, so this one is part A. Here is the circuit. For this circuit, we have two flip-flops, and we use two JK flip-flop, J1, K1, J2, K2, Q, Q bar, Q, Q bar, and for the inputs we have AND gate here, and we have OR gate here. The AND gate is connected to J1, and the other input of the AND gate is coming from Q of the second JK flip-flop. So it's here. The first input of the AND gate is coming from input X. So input X is connected to the first input of first AND gate, and let's just invert the X in case we need it. J2 also is connected to X. J2 also is connected to X, and J2 is connected to OR gate, and the first input of OR gate is connected to X bar, and the second input of OR gate is connected to the Q bar of the first flip-flop. What else? The output of the Q output of first flip-flop is connected to an AND gate and gives like the output. The other input of the AND gate for the Z is coming from J1, like this. Let's see what else we have. I think we done. Okay. And by the way, we also have a common clock is connected to both flip-flops. So it's clock cycle. Okay, we want to analyze this circuit and find the output. The first thing we should define, as you remember, are input, current state and next states, and like the output. The next states of first flip-flop, the current state, the current state of the first flip-flop, we show it with lowercase y1 and y1 bar, and for the second flip-flop y2. Okay, and we need to find the output of each combinational part of the circuit. So the output of first and OR is X, Y2. The output of OR gate is X bar, y1 bar, x bar plus y1 bar, and the output z is equal to x y2 y1. Okay, and capital Y, of course, this one is not a D flip-flop, but the capital Y is like determined by J1 K1 and J2 K2. We don't write capital Y. Instead of capital Y, we know that the capital Y1 is like a combination of J1 and K1, and capital Y2 is combination of J2 and K2. So we work with J1, K1, J2, K2 instead of capital Y1 and capital Y2. Okay, so now that we reached to this point, we need to write the equations. So we say J1 is equal to xy2. K1 is equal to, oh, I forgot to connect K1. Sorry. K1 is connected to X bar. Okay. K1 is X bar. J2 is X. K2 is X bar, Y1 bar. X bar plus Y1 bar. Now that we have this equations, we don't want to do timing diagram at this moment, so we need to find the state table. So how we can find the state table for a circuit with more than one flip-flop? For one flip-flop, for the circuits with one flip-flop, we know that we can just write the state table and fill different cells. But for more than one flip-flop, the story is a little different. We should draw the tables for each individual flip-flop and then combine those tables. So we draw it separate timing state table the state table for each flip-flop and then combine them. Okay, so let's do that. First, we are going to find the next state y1, which is related to flip-flop number 1. So we draw a table. Okay, how many states do we have? Of course, we have 4 different states. Also, we just trying to find next state of y1, but still 2 flip-flops are involved in the circuit, so there are 2 different possible states. So the input is x and the present state is y1 y2. So y1 y2 is 0 0 0 1 1 1 and 1 0. Why I didn't say 0 1 0 0 0 1 1 0 1 1? Because we might need to simplify these tables later using a Carnot map, so it's the reason we show in this way. And the input, of course, is 0 and 1. Okay, so let's start by completing this table. But because this is for y1 flip-flop 1, so let me change the color of present states of y1. So these are y1. Okay, and of course we know that j1 is equal to x y2 x y2. j1 is x y2. Let me just j1 is x y2 and k1 is equal to x bar. Okay, now let's solve it cell by cell. First of all, I want to focus on this first cell. For the first cell, we see that y1 is 0, y2 is 0, and x is 0. So can you tell me what is j1? Of course, j1 is equal to x y2. X y2 both are 0, so j1 is 0. What is k1? I don't know why my pen not working properly. K1, just give me a minute, second. K1 is equal to x bar. What is x? Of course, x is 0, so k1 will be equal to 1. What does it mean? j1 is equal to 0, k1 is j is equal to 0, k is equal to 1. It means a reset. A reset means output next state is 0. So we can say next state is 0. That's it. Let's just do one more table together. Let's just focus on this cell. This cell. For this cell, J1 is, so don't forget, we talking about Y1. What is Y1? Y1 is next state of this flip-flop. Okay? So, Y, so j1 is equal to xy2. Xy2 is of course is equal to 0. K1 which is equal to x bar, which here will be equal to 0 because x is 1. So what does j1 k1 means? Sorry, what does j equals 0, k equals 0 means? It means no change. So present state of the y1 will be next state. What is the present state? The present state is 0. So this 0 moves here. So this one is 0. Let's move to the next cell. Next cell, let's say is here. Here, j1 is equal to xy2. xy2 is equal to 0. What is k1? K1, of course, again is equal to x bar, which is equal to 1. So this one means reset. Reset means y1 should be equal to 0. So we put 0 here. Let's move to the next state. Here, next cell. J1 is equal to J1 is equal to 0. No. Let me. J1 is equal to x y2. X is 1, y2 is 1, so j1 is 1. j1 is 1. What is k1? K1 is x is 1, so x bar is 0. So j1, j equal to 1, k equal to 0 means set, or means y1 is equal to 1. So we say y1 is equal to 1. So now pause the video and try to complete the next four cells, and then compare your results with my solution. Okay, so we got this value so far. We got 0, 0, 0, 1, and we know that j1 is equal to x y2, and k1 is equal to x bar. So just compare your solutions with my solution. I hope that you all got the correct answer. So for this cell, j1 is equal to x, which is 0, y2, which is y, is equal to 0, k1 is equal to x bar, which is y. So j equal to 0, k equal to 1 means reset. Okay, means reset. And it means reset, or means y1 equal to 0. So y1 is equal to 0. For the next cell, which is here, we know that j1 is equal to x, which is 1, y2, which is 1, so it's 1, k1 is x bar y, which is y bar, which is 0. 1, 0 means set, means capital Y1 is equal to 1. So capital Y, which is next state, is equal to 1. The next cell, here, J1 is equal to X Y2. What is Y2? Is 0, which is 0. K1 is equal to 0 bar, which is 1. 0, 1 means reset. So it means y1 is equal to 0. So y1 is equal to 0, sorry. And finally, the last cell, j1 is equal to x y2, x is 1, y2 is 0, so it means 0, j1, k1 is equal to 1 bar, which is 0, 0, 0 means no change. No change. What is the previous value of x1? y1 is, oh sorry, it was 1. Let me fix it. It was 1. So the previous value, so the current value will be the next value. So it's 1. Okay, so this one is the state table for flip-flop number 1. So when we reach to this point, we done with flip-flop number 1. We need to erase all these calculations because we need to repeat the same thing for flip-flop number 2. Okay, so Let me make sure that it is recording. Okay. So this one was next state of y1, flip-flop 1. For flip-flop 2, we again draw the same state table. Again, the same thing. X is here, 0, 1. Y1, Y2, lowercase y1, y2, y1, y2, 0, 0, 0, 1, 1, 1, 1, 0. So let me change the colors of y2 because this time we are focusing on y2. So y2. And we know that j2 is x and k2 is x bar plus y bar, y bar, y1 bar. If we repeat the same calculations we did for uh, state table 1, I recommend you to pause the video and try to fill entire this table and then play the video and compare your solutions with my solution. So for here j2 is equal to 0, k2 is equal to 0, it means reset. So the value is 0. For here j2 is 1, k2 is 0 plus 1, 0 plus 1, which is 1. So j2 is 1, k2 is 1 means complement, or y2 bar. What is y2? y2 of course has a value of 0, so it will be complemented and here will be 1. Okay, the same thing for example for this cell. For this cell j2 is 1, which is x, k2 is x bar, which is 0 plus y1 bar. Y1 is 0, y1 is 0, so it's 0 bar, which is 1, so it is 1. So again it means complement, so we should put y2 bar. So y2 bar, again move y2 is 1, so y2 bar is 0. It moves here. So for this cell j2 is 0, k2 is equal to x bar, which is 1 plus, like we don't care what is y1 bar because one of the inputs is 1, so k2 definitely is 1. So j2 is 0, k2 is 1, it means reset. So y2 should be equal to 0. The next one here, j2 is 0, k2 is equal to 0 plus y1 bar. y1 is 1 bar, it's 0, so it's 0, it means no change. No change. What is the previous value of y2? The previous value 0, 0 is no change. Let me just double check this one. It is 0 and k2 is 0 plus 0, not 0, yeah, it's not 0, sorry, it's 1. 1 plus 1 bar, which is equal to 1, and it means reset. Not, no, sorry, it's reset. So this one will be 0. Let me erase this part because I want to continue for the next cells. For this cell, J2 is 1, K2 is 1 bar plus Y1 bar, which is 0, it's 0. Okay, so 1 0 means set, so Y2 should be equal to 1. For this cell, J2 is 0, K2 is X bar, which is 1, plus any value will be equal to 1, so it means reset. So here is 0. And finally, last not the least, J2 is equal to 1, K2 is equal to X bar plus Y1 bar, which is Y1 bar, which is here, and which is 0, and this one means set. So this one is a value of 1. So you see we have completed the 2 timing state table for this example, and now after finishing these individual timing tables, we need not timing table, state table, we need to find the output as well. So let me erase all these notes. Okay, now that we reached to this point, let's just draw another table, but this time for the output. For the output, here is x, y1, y2, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. Okay, what is z? Z is equal to x, y1, y2. So x is 1, z is 1 if all x, y1 and y2 are equal to 1. So the only cell which x, y1 and y2 all are 1 is this cell, and the other cells will be equal to 0. So this one is z. So we got to this point. It's time to continue by combining these. So this one was z. By combining these 3 tables together, we need to combine them together and have our like main state table. So what we do again, we draw a table. Okay, and we say x, y1, y2, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So what we do, it's simple. Just we take this value, we take this value, this value, this value together and put it in this cell. We take for example, this value, this value, this value together and put it in this cell. Okay? So just we copy paste data from these 3 individual tables to a complete table. So if we do that, so we will have 0, 0 over 0, 0, 1 over 0, 0, 0 output 0, 1, 0 output 0, next state 0, 0 output 0, next state 1 1 output 1, next state 0 0 output 0, next state 1 1 output 0. Okay, this one is the timing table, and what we need to do now, it's like we need to do state symbol assignment. We assign a symbol for each state. So we say, for example, state A is 0 0, state B is 0 1, state C is 1 1, and state D is 1 0. So we continue by drawing the table again. Okay, we have X, we have Y1, Y2, states A, B, C, D, input 0 and 1, and next state A output 0, next state B output 0, next state A output 0, next state D output 0, next state A output 0, next state C output 1, next state A output 0, and next state C output 0. And so these are next states and output. Each of these cells. Okay, and we done. We found the state table. We can draw the state diagram using this state table, which I recommend you to do that as a like practice. And part B of this example says draw the timing diagram if x is equal to 0. Oh, it's not working, the pen. Let me make sure. If x is equal to 0. Oh, I'm sorry, I don't know why it's not working. 0 1 1 1 1 0 0 in this direction. We need to draw the timing table, and of course initial state is y1 0 y2 0 is equal to 1 0. Okay, try to do this by yourself, and we will continue drawing this solving this part of the problem in the next lecture.